Okay, following on from my previous video then of deriving the Maclaurin series, we're going to have some examples of the Maclaurin series. The derivation you don't need to know, you just need to know this, which you're given in the formula book, I think. Should probably check that before the video, but I don't know. You can check it yourself. Either way, this is what we're going to be using. So I've got f of x is sine of x as a first example. And I'm going to write this as a Maclaurin series. I'm going to say that sine of x is approximately equal to a constant plus another constant times x plus another constant times x squared plus another constant times x cubed, and so on. I'm going to find the values of these constants by using this definition here. So what we're going to need to do is find the derivatives of sine. So f dashed of x is cos of x. F double dashed of x is minus sine of x. F triple dashed of x is minus cos of x. And the fourth derivative of x, I tend to write Roman numerals for my derivatives, but that's just in case you're unaware there. Yeah, it's the fourth derivative, is sine x. So that allows me to state that f primed of 0 is 1, f double primed of 0 is 0, f triple primed of 0 is minus 1, and f to the fourth of 0 is 0. And I also have that f of 0 is 0 because sine of 0 is 0. So we got the pattern, and what we're actually going to get then is that every other term is going to flip-flop between 1 and minus 1, and the ones in between are all going to be 0. So the constant will be 0. That'll be 1, so linear term. That'll be 0. That'll be minus 1. Well, minus 1 over 3 factorial, and so on. Okay. So therefore, sine of x is equal to, when r is 1, that's 1. Sorry, yeah, when r is 1, so it's the first derivative, so it's 1. So that's 1. Over 1 factorial, that's 1, so it's 1 over 1. X to the 1, so it's just x. When r is 2, I'll get the second derivative, but we know that's 0, so we can ignore that. When r is 3, we'll get the third derivative. Well, the third derivative is minus 1. Divided by 3 factorial is 6, so I get minus a sixth x cubed. Okay. The fourth derivative is 0, so therefore again this term will be 0. The fifth derivative will be positive 1 again, because it's going to cycle through these 4 numbers. So it's going to be positive 1, divided by 5 factorial, which is 120. So it's 1 over 120, x to the 5. And it'll be minus 1 over 7 factorial, x to the 7, plus 1 over 9 factorial, x to the 9. And I can continue. The pattern continues. So I could actually just summarise that into one series, which says that sine of x is equal to the sum of minus 1 to the r from r equals 0 to infinity. I want this to be 1 when r is 0, so it's going to be 2r plus 1 factorial times x to the 2r plus 1. So when r is 0, it's positive. It's over 1 factorial, it's x to the 1. I'll give you that term. When r is 1, it'll be negative. It'll be over 3 factorial, and it'll be x cubed, so that'll be that term. When r is 2, it'll be positive again. It'll be over 5 factorial, x to the 5, which is this term. And when r is 3, it'll be negative again, over 7 factorial times x to the 7, which is this term, and the pattern continues. Okay, so that is the Maclaurin series for sine of x, which actually is its power series. Okay, that is its power series. You can do something similar for cos. I'm not going to do cos. Maybe you could try the cosine function yourselves and see what you get. Another example, e to the x. Notice also actually that sine is an odd function. Okay, it's got rotational symmetry about the origin. And all of these are odd powers. That's not a coincidence. Okay, cos will only have the even powers because it's an even function. This is neither even nor odd, so we can expect even and odd powers in my power series. So f primed of x is e to the x, and in fact, f to the rth derivative of x is e to the x, which means that all derivatives at 0 are 1. All derivatives at x is 0 are 1. So it's just 1, 1, 1, 1, 1 in that place, in that position there. So e to the x then becomes very simple, and is going to be 1 plus x plus a half x squared plus a sixth x cubed plus 1 over 24 x to the 4 and so on. And e to the x is equal to, as a power series, r equals 0 to infinity of x to the r over r factorial. And that is the power series for e to the x. Okay, and that's because all its derivatives are 1, so it's very straightforward. Okay, second example. Third example, log. I've included this one because it's not true for all x. There's actually a restriction on it, whereas the others are true for all x. So we'll look at that. Also, it's log of 1 plus x, because you can't do the Maclaurin series of log of x because it's not defined at x is 0. So it has no value nor derivatives at that point. So we translate it to the left by 1 so that it's all valid at x is 0. So I'm just going to do the first couple of derivatives. So f, well, I did more than a couple actually. F primed of x is going to be 1 plus x to the minus 1. F double primed of x is minus 1 into 1 plus x to the minus 2. F triple primed of x is 2 into 1 plus x to the minus 3. F to the fourth derivative of x is minus 6 to 1 plus x to the minus 4. You get the idea, hopefully. So f primed of 0 is 1. F double primed of 0 is minus 1. F triple primed of 0 is 2. And f to the fourth derivative of 0 is minus 6. And the general rth derivative of 0. Again, we can see it flip-flopping between positive and negative. So it's going to be minus 1 to the r minus 1, because when r is 1, I want it to be positive. And that's going to be divided by r minus 1 factorial. Okay, it's kind of like it's out of phase really, because it's got r minus 1 kicking around. But there you go. Oh, no, it's not divided, is it? It's times. There we go. So that's the rth derivative of this function at a general point. And again, we can plug these into here. So we'll get that log of 1 plus x is equal to, when it's 0, well, f of 0 is 0, so actually there's no constant term. 1 over 1 factorial, so that's just x. Minus 1 over 2 factorial is minus a half x squared. 2 over 3 factorial is plus a third x cubed. Minus 6 over 4 factorial is minus a quarter x to the 4, and I'll get plus a fifth x to the 5, and so on. So in general, this is equal to the sum from r equals 1 to infinity of minus 1 to the r minus 1 over r times x to the r. And this is not valid for all x because we've lost a factorial on the bottom. So because there's a factorial in the derivatives, it means we've lost the factorial in the bottom, so that it doesn't converge if this is bigger than 1. So this is actually only valid for modulus of x is less than 1, i.e. between -1 and 1. Okay. And the final one, I know I've not covered this yet in any of my videos, but they will be up when we do calculus a bit later on in the year, so I thought I'd include it now. Anyway, we're just going to do the first couple of terms of this Maclaurin series. So differentiate this is equal to 1 over the square root of 1 minus x squared, and then we can differentiate that again. So I'm going to say that's equal to 1 over root u, where u equals 1 minus x squared. So du by dx is minus 2x, and I'll get that f double primed of x is equal to minus a half u to the minus 3/2 times minus 2x. That's using the chain rule. So that gives me 2x divided by 1 minus x squared to the 3 over 2. I should really differentiate that again, because when x is 0, that's going to be 0, so it's going to be a bit trivial. So I'm going to differentiate it again. F triple dashed of x, and it's going to be the product rule this time. So I'm going to do that times the differential of that, so it's just going to be 2 over 1 minus x squared to the 3 on 2. Plus 2x times the derivative of this. So that's going to multiply by 3 on 2. That's going to come down by another 1. So it's going to be minus 5 on 2. And I need to multiply by the 2x, minus 2x inside. So that comes out to be 2 over 1 minus x squared to the 3/2 from this term. The two negatives cancel, so it's positive. The 2 will cancel with that 2. I'm left with 3 times 2 is 6. Got 6x squared. Divided by 1 minus x squared to the 5 on 2. So that's its second derivative. That allows me then to state f of 0 as 0, f primed of 0 as 1, f double primed of 0 as 0, and f triple primed of 0 is 2. That allows me to state then that arcsine of x is approximately equal to x plus, got 2 for this, the third derivative, so that's going to be 2 over 6, which is a third, x cubed. Okay. And if you wanted more terms, you'd have to find more derivatives, but we're going to stop at the second derivative, the second term. That's an approximation, that one. Okay. And that is the Maclaurin series. Thank you.